Hello everyone, this is Saru speaking, and today we would be discussing about the advantage of building an internal developer platform, what it enables the developer to do. So one of the thing is the title says maximizing efficiency and collaboration. So the strategic benefit of implementing a fully featured internal developer platform, and we would be seeing a demo at the end, uh, powered by Backstage and Kubernetes. So, Internet Developer Platform is one of the most popular term these days. Rather than having a DevOps uh, team altogether, we have a platform engineering team building an internal developer platform which uh, takes care of providing all the resources the developer needs, making it as seamless as possible for the developer to utilize. So, yeah, definition of an internal developer platform. An internal developer platform is a centralized platform that empowers developers to efficiently manage applications, services, and infrastructures in their organization. It provides a seamless and collaborative environment for the software developer team, so enabling the developers to build a high quality product with as easy as possible. So, some of the benefits of IDP that we would be covering up is like we would be just talking about a few, but there are many. But yeah, so streamlined workflows and enhanced productivity. We try to make these teams collaborate, share resources among each other, so that the and with that too with a very ease way, and this enhance the productivity of the developers altogether. So improve collaboration and communication. The team should be able to have an understanding of what the other team is building, what are the APIs, what are the docs, what are the other things that it can utilize within the organization, some of the existing frameworks, some of the existing libraries that are there should be easily accessible by the other teams to utilize, which becomes quite difficult in a large organization where multiple teams on multiple technologies are collaborating with each other. Apart from that, an accelerated development and a faster time to market, it would try to have some kind of standardized automatic way. As things are standardized as in an IDP, generally we tend to make it a standard. It enhances the uh, getting up from an application from a scratch application to getting into production as a click of a button. We might see something in the demo which would make us understand what it is. So, some of the key features of Backstage and Kubernetes we would be utilizing. So, Backstage and Kubernetes both are CNCF uh, mm, CNCF project, and we would be utilizing both. These are the two popular platforms. So Kubernetes is the orchestration platform, as we all know, for running our containers. It has been a de facto standard since it has come to picture. And Backstage is kind of a platform that is built by Spotify. They internally use it, and uh, it can be extended through plugins. There are community plugins and other things that can be utilized to make those. Make an internal developer platform for your particular organization as per the need. So, to successfully implement a internal developer platform, we need to understand the requirements of an organization, how it would work. Some of the definitely the second thing would be to document it and train the developers to utilize it in an efficient way. And this actually brings up a culture to be utilized. Uh, Within the organization, everybody has some standards and can speak to each other in similar terminologies. So, few of the case studies that we would see that Spotify, which actually built Backstage, is using it as their internal developer platform. They have an extended version, resulting in around 60% decrease in the development cycle and 50% increase in the overall developer satisfaction and experience. Google, on the other hand, is using Kubernetes to provide 99.99% of the uptimes, It is scalable and it has proved to be a 50% reduction in the infrastructure provisioning time, which is a lot. So we definitely see that having an internal developer platform, maybe it's Backstage or anything, but having it for your organization drastically reduces the time to market, increases the efficiency of the developers, helps teams to collaborate, and keep things in a standardized format. So now we are at the skin of Kubeos, which is an internal developer platform. It's kind of an MVP, giving it a glimpse and a taste of how the internal developer platform should be, maybe giving it an efficiency of what it can bring on the table. So this could be said as a home page for now, and uh, we can see some of the components that are within the organization. That is Flagger load tester, Istio being a service mesh, Jaeger for telemetry, this CubeOS, which is actually the internal developer platform also. It has a baseline which is providing the base for all the applications to be deployed. The CubeOS cluster, which actually syncs with the Kubernetes cluster. It uses Flux CD to do that. A CubeOS GitHub workflow, which actually helps in managing all the workflows at one place so that it can be utilized by different teams, by different templates, by different applications building their own pipeline is quite daunting and becomes quite difficult to manage. Uh, Prometheus stack. This is for metrics, what understanding how the application is behaving at runtime, and Vault to provide like secret management for the organization. So yeah, let's see. We can see there is a create button. I can uh, go ahead. Let's see what are the options. Okay, so I have some templates over here. I can see QoS .NET Clean Architecture template. We have the Angular template. We have .NET 7 API in Kubernetes, and we have some Node.js jobs that we can build. So we would be taking a look at the templates, but going back, take a looking at okay what Flagger or any other resources look like. So these are components within the Backstage, which can be uh, uh, providing as individual isolated software or a library which could be utilized by other, can be dependent on some other libraries, and Backstage just helps us visualize what is the dependency and who owns the product. So let's go on to Flagger, take a look at it. Okay, so we can see that Flagger is uh, owned by the group platform engineering team. It is a part of the Flux baseline, and uh, the system that it belongs to is a QoS IDP, that is the internal developer platform system. So, okay, we could have some code insights so we can see, okay, what it is made of, having a glimpse of the repo altogether. This is a plugin by GitHub. We can extend it to have some other functionalities. These are open source community plugins which we have utilized mostly. We can see some of the documents around Flagger if we have any. It uses the temp docs, which is also tech docs, which is also a part of Flagger Backstage, and this is a plugin can be utilized. So we can the Flagger have its own documentation. We can see if it has any. Yeah. So once I have logged in using my GitHub, I can see there is no CI/CD. We have no pull request. We can go into the Kubernetes tab. We can see, okay, it is running in the cluster. We can see there is one pod running. We can even click on this pod to see some of the YAMLs that we want, which is used to deploy it. We can have some managed fields. We can have the logs of the application that is running inside the Kubernetes. So basically, we are bringing everything over here rather than developer going uh, to 15 different windows and accessing something. It becomes a one place. Any kind of provider's API, any kind of API it consumes, any kind of API that this component provides. Currently, Flag doesn't. So yeah, we have the Prometheus, the dependencies, which will be coming back later. So yeah, this gives us a brief overview of what how things look like. Briefly going on the some of the repos to point out. The Kubeos workflows keeps the GitHub workflows. The cluster syncs the repo to the current cluster, which I have running it in the local environment right now. And Kubeos baselines provide the base, which Flux takes care of synchronizing it with the current cluster. The baselines we can go over here, we can see it has Flagger load tester, Istio Jaeger, and Prometheus and Vault. So these are some of the predefined uh, add-ons that it has, which would be deployed whenever an application or whenever the Cubase baseline is referenced within the cluster. So yeah, uh, so yeah, let's go back and uh, to the template section and see. Okay, let's try and create how easy it is to get onboarded into an application. Getting an onboarded new application into the organization. How seamless it is to get. Uh, let's just choose it. Uh, okay, so I want to create a .NET project. Let's say demo API IDP. Just say demo API. You can have the description, basically anything. Let's assign this component who would be the owner, let's say backend team, and the system it belongs to maybe a shopping app. We can add dependencies. What APIs does it depends on? So we have an auth API that might be used by all the products or all the all the components or all the services within the organization. Uh, the it can depend on other components. Maybe it has some secrets involved. It can have some other dependencies as well, maybe Flagger. Uh, it can have any other dependencies, say Jaeger, which is exporting some of the uh, tracing data to trace out. It might have some dependencies on Prometheus stack because it is experiencing some exposing some metrics out. Uh, let's say maybe that's all. Uh, okay. Now let's configure the repository settings for it. I will say it's GitHub, and let's say demo API. This would be the repository for me. This is the I'll use demo API itself. Okay, so I'll just press next, and this gives us a brief of okay what things are there, what we have configured. Let's click on create. As we just press create, it fetches the skeleton that is provided for the .NET template. It creates a new repo in the publish main, creates a new repo with the name that we have suggested. Now it is trying to fetch some of the remote customizations because .NET needs to be deployed on a Kubernetes environment. So there might be some remote entries that we need to do. Uh, Sending the PR to the repo and registering the application into the Backstage itself. So once the developer has created this, it would be uh, let's just say the best advantage of an ITP could be that the person or the developer doesn't need to go anywhere. So we have started an application from its scratch, and let's just see it in catalog itself. So I can see I'm in the catalog, and I can see I have the demo API. I can see some of the other services that it depends on that we have selected. So it consumes an auth API. It is dependent on Flagger, Jaeger, GitHub workflows. It has Prometheus stack dependency, and also it is dependent on Vault. It is has a part is a part of the shopping app. It exposes a demo API, and a backend team is the owner of it. Now, if I go to the code insights right now, maybe the API that it exposes, I go to the definition and we will see that this is currently just weather forecast. This is the default uh, open API spec that is already there. But this API actually exposes a different endpoint. It exposes three. So meanwhile, let's see where it is actually. So let's go back. We can see the demo API being registered in our component section. We can go over here, and rather than going all around to the other areas to see what is the status of things, we can just have a code insight over here. Okay, it is a C sharp project. It has a Docker file. We can go to the documentation, but the most interesting thing is having a CI/CD pipeline. So we can see this is an initial commit of the demo API. If we go over here, we can see the status is completed. Uh, so the application was built. The application, after being built, was uh, updated the Open API spec, and after that, it published something to Docker. That is the image of this application. Uh, okay. Is it running on the Kubernetes? No, it is not. So how can we get it into Kubernetes and how easy it is? So as I said before, that this would be creating a PR to the cluster repo. So if I go back to the cluster repo and I go to pull request section, I can see, okay, a demo API PR has been created. I can see, okay, this is committing project demo API for deployment. I can click on this link, go to GitHub. Now I can see the files that are being changed and merge this request. But let's just see, okay, few of the files that have been changed. These are, it is registering a Git repository in the cluster. These are some of the Flux CD tools, Flux CD custom resource definitions, applying the customization. Now over here we have where are the customization, where the deployment files for this particular application. It's just inside the application. The application also knows what manifestors needs to use, takes care of what manifestors it needs to use. The cluster just provides the customization for it. And if we see, we are just registering those customizations. So yeah, as we see, if we are good, we can just say, uh, we can just go back. Yeah. And let's say we merge this request. Now once this, so after merging the change, I come back to the Backstage application. Um, the feature could be added to the Backstage, but yeah, currently we have to go to GitHub, the source repo. Now we can go back to the demo API and let's check back if there is any updates on the API section which needs to be done by the CI pipeline. So let's go to the definition and we see a new metric test. This is a new endpoint that has been added. I can try it out. Currently, this environment is not ready. So yeah, let's go back. So we see uh, the demo API being running over here, and there are few things. Okay. So currently we see this application uses a secret, but we are unable to fetch it over here. This is because of an error in the application itself. So let's see if we can resolve it and how soon can we get it up and running. So let's go to GitHub. Now I am in the GitHub demo API over here, and we can see this new repo that has been created just 23 minutes ago. So we saw some error in the Backstage application. Let's try to resolve it and how soon things would go. So let's just edit this, and instead of demo API, let's give the path be dev and commit the change. Now coming back to the Backstage application, once the developer has changed it, created a PR, we can see there is no pull request. We didn't create a PR, but yeah, in the CD pipeline we can see a new uh, as we updated it directly with the same message, and the update catalog to info has been updated. Now we can go to this. Currently it is queued as yeah. We can see the workflow in GitHub, but we don't want to see it now. Uh, Provided we can also see the other command. We can see if over here we can go to the log section and view the logs of the whole running pipeline, and similarly we'll be able to see for the other one. Let's just go back document, and we can see this is currently queued, so we won't be able to see much of it, but yeah, whatever things have been running so far we'll be able to see it. So yeah, mm, currently if we see the demo API, so we merge the changes. Let's see if it is running on Kubernetes or not. We can see, okay, there is a pod running and a service running for this particular. We can see, okay, this is the pod, and we can see currently there are two containers running. One is the Vault agent and one is the demo API. We can see the logs for this. It is a .NET application which is serving on port 8080. Let's just go back, and we can see the Vault agent. It has written the token, and it has, oh, sorry, yeah. So yeah, so it has successfully initiated the application. If you see the YAML, we have the path telling, okay, agent and check this secret. Now, how does the application know the secret needs to be created, or this application actually needs to have access to this particular path? Now, how can this be done? So, if we go back, so now we see we have made a change in this application to just use show the path for secrets, and we can see that the vault is now showing up correctly. It is showing what are the secrets used by demo API currently being the access. We can have it defined at access levels, like which application would be able to see which secrets over here. But yeah, so going back to Kubernetes, how did the secret get generated, and how did its access being? So to this, we have this Kubeos vault sync which we have made. This actually synchronizes whatever the secrets has been requested by the application. Now, how does the application make the request to have those secrets and access in place? So go to demo API. So now we're in the demo API. Let's go to deploy. Let's see the base. We have the secret. This is application secret, but if we see, we have the vault role policy sync. So this is the vault sync config which would be used to create a role with the same name, which then can be utilized by the deployment. So the deployment, if we see over here, is using the same role. So there is a vault policy and role synchronizer running in the Kubernetes cluster, which looks for this config map having the label vault config that creates the config map automatically. So the application, if wants to create a different role, they might need to come up and change here the name, and that would be done. So the application takes care of everything that the application team needs to take care of. Its own source code, anything that requires to have a its deployment in the cluster, the Backstage specific resources, and or the internal developer platform specific resources, and also the documentation for it. It is in a standardized format how things should look like, and every template within the organization could follow the same standards. Here we can see that the policies for a demo API has been created. It has the ability to read from this path, and a secret for this particular application for a dummy secret has also been created. Backstage also could have a metrics and tracing capability. As the application is now standardized, all of them might be using the same standard of uh, basically of open telemetry and Prometheus as a standard metrics exporter, or maybe if you want to export a full metric having it some resource outside other than Prometheus, you might end up creating our own plugin. So we can see some of the Prometheus alerts for a particular uh, for this particular vault sync. We can see some of the uh, alerts that has been raised. Currently, it has been configured to show all the alerts over here, so it's not specific to a particular service, but that can be done through the rules and methods. Apart from that, we can see the dependencies has been configured. So the demo API is dependent on Flagger, it is dependent on Jaeger, the GitHub workflows, and the what. So yeah. So going a bit further to see the other things come as out of the box and makes it so easy for the developers. So we might actually go and see some of the Prometheus and Jaeger metrics and tracing data. As we are using any standardized format for the applications now, maybe so all the metrics can be collected, and so the application is by default the template can be configured to have these settings already in place. So once as soon as the application gets onboarded to the cluster in the Kubernetes, it automatically is configured to expose these metrics and the tracing data. So we can see over here, this is the run count. If I execute it, we can see, okay, in the demo API, this is the one, it is running in dev namespace, this is the pod, and so we can confirm, okay, so it is able to collect metrics as an advantage of being a standardized format all across the organization. It becomes very easy to onboard into. And coming to Jaeger, we can see the Jaeger has started would be able to see the collector would be able to connect tracing data, and we can see the demo API. So let's see and try to find the traces. If we can see, okay, so the health checks and the metrics endpoint are being invoked by the Kubernetes, and the metrics endpoint for Prometheus is actually being working fine, and we can see uh, basically how the endpoints behave. Uh, so we have added some functionality to the endpoint that we saw, that is outgoing HTTP request. So if we go to demo API, I just made a call to this endpoint, and if we go to this, we can see the weather forecast outgoing request. What this endpoint is capable of currently doing is it's just sending a request to the other URL which was sent in the URL parameter. So if we see over here, it was currently the request that I made was for the google.com. And if we see over here, we can see that the demo API made a request to google.com, and it returned status 301, and the get method returned at the entry 200. So we can see how did the request take took time and which part actually took most of the time. Uh, So it could have multiple hierarchy of information, but the one API calling the other API. So we just saw a glimpse of and a taste of how the IDP could look like. We will try to explore more, just briefly. So going back and brushing up all the things, it could have some of the links that it has, like the issues page and other links that it could have. You could view the source by clicking over here. Uh, it shows all the relations that the component has. It has all the subcomponents it has, what are the status of the pull requests. These are additional plugins that we need to, and the vault secrets that the application is using. You can straightforwardly click over here. It would take us to uh, the vault UI, and we can see the secrets. The code inside shows us how the application readme about the application readme and some of the insights that the GitHub actually provides. Going on to the tech documentation, it can have its own documentation. The demo API, it takes the power of mkdocs and try to utilize that. This is an additional plugin by the name TechDocs. We are able to see some of the CI/CD info. We also saw the logs. If a pull request is created, it would be capable of showing it. Uh, we have the Kubernetes deployment. We can actually see other details related to the deployment and the YAML of it. It has what are the APIs that it consumes and what is the API that it provides. Some Prometheus alerts. And so going back, if we see the API documentation, we have the API, so that we can say what are the systems, what are the APIs that the current organization has. Uh, what domain things are being working on. These are core services. Inside that, the core services have a shopping app and few of the templates that could be registered. So um, the organization working with different uh, technologies and different stacks can come up with own template, and that becomes a standard for any of the application that we need to start from scratch. This also helps in enhancing the development of a POC, which actually reduces the time of configuring a POC in case we require some additional capabilities. The application, when built from the template, already provides you things out of the box. Uh, yeah, so this is basically uh, what the IDP would generally look like. Backstage is one of the very powerful tools that we can utilize to have it, and oh, we can explore the much of the graph. If we see over here, currently it's just showing one depth. We can explore it to four, and it can uh, give you a much level of insight, uh, which is quite powerful. Uh, mm, and yeah, that's all I guess. Uh, thank you.